Alright, I want to talk with you guys a little bit about normal distributions. In particular, I want to talk about understanding areas and probabilities and how we can use Microsoft Excel to calculate these quickly and easily for application's sake. So to start getting our hands dirty, let's talk about a very common scenario that possesses normally distributed data. IQ scores. The Wechsler Adult Intelligence Scale is an IQ scale that whose test yields normally distributed scores with an average of 100 and a standard deviation of 115. So that's an important part I need to add in there for you guys. So without this bit of information, we actually can't do what I'm about to ask you to do. I would like to look at the probability that a randomly selected adult scores between 85 and 115 on the Wechsler Adult Intelligence Test. Well, hopefully you're starting to get accustomed to this and you recognize something right off the bat. This guy, that's what? That's mu minus sigma. And then if we look over here, that's mu plus sigma. So the empirical rule is telling us expect approximately 68% of the data to lie within one standard deviation of the mean. So while I don't go into this question expecting exactly that, I certainly look at this probability and say, I expect something in the realm of 0.68. That seems very reasonable. Right? We always need to be exercising our intuition as we step into the realm of probability. It's very, very important that you begin to develop your intuition for what is reasonable in terms of likelihood. So let's keep in mind that the empirical rule is telling us that the probability a randomly selected adult scores between 85 and 115 on the Wechsler Adult Intelligence Test is approximately 0.68. We know now that a particular likelihood is associated with an area under the normal probability density curve. In this particular case, we're looking for the area in between 115 and 85 for this normally distributed data set. We also know at this point that one way to find this particular area is to find the area left of 115. Alright, which is all that shaded in blue right here, and subtract from that the area left of 85. It's important that we remember this because Microsoft Excel's cumulative density function is going to give us areas left of the particular random variable of interest. So let's go ahead and jump into Microsoft Excel and look at, in particular, the probability that the random variable would be less than 115 and the probability that the random variable would be less than 85.
So we're trying to determine the probability that a randomly selected adult would have an IQ between 85 and 115 according to the Wechsler Adult Intelligence Scale. So we determined that that would be equal to the probability that a randomly selected individual would be less than 115 minus the probability that the randomly selected individual would be less than 85. Now, we could calculate these individually and subtract them, but that would be kind of silly when we're using a piece of software that can do that quickly and easily for us. Now recall that mu and sigma, right? Mu and sigma from our distribution were 100 and 15 respectively. Okay, and since scores were normally distributed, I know I can use the norm.dist function, right? So I say equals norm, and I start typing norm, my autocomplete menu comes up for me, and with norm.dist highlighted, I can just hit tab and that'll autocomplete it for me. Okay, now remember this function, if I treat it as a cumulative distribution function, will give me area to the left of the random variable that I'm selecting. Okay, so you can see I need 4 inputs, right? The random variable, which in the first case is 115, right? With a mean of 100, a standard deviation of 15, And then I get to the Boolean piece of the argument, which is true or false. And again, true will treat it as a cumulative distribution function. False will treat it as just a probability density function and will give me the height of the curve at that location, which with a continuous distribution doesn't do me a whole lot of good at the moment. So I'm going to choose true, and that will give me area left of this. Now I don't have to hit enter yet. I'm going to go ahead and calculate 85 at the same time. So I'm going to say minus, I start typing norm.dist again, autocomplete. I'm going left of 85 this time. So 85 with a mean of 100, a standard deviation of 15, and again I'll choose true because I want cumulative area left of. Right? So this is doing area left of 115 minus area left of 85. So I'll go ahead and execute that. And you can see I expected something at approximately 0.68, and this is telling me exactly 0.68269, etc. Right? Probably goes on a little past that. But if we were to round to the nearest thousandth or 10,000th, so let's just round to the nearest thousandth for now, that would be 0.683. So in other words, the probability a randomly selected adult has an intelligence or an IQ between 85 and 115 according to the Wechsler Adult Intelligence Scale, rounded to the nearest thousandth would be 0.683. So you see now this is quite a bit handier than calculating z-scores by hand and going to a standard normal table, and in fact it's actually more accurate as well. So ideally at this point you're starting to get a little bit more comfortable with Excel, and we'll continue to use it and develop our skill set as we move into confidence intervals and hypothesis tests in the future.